Because of the human activities, we are releasing 35 billion ton of carbon dioxide every year. Now this is coming almost 3/4 from the fossil fuel use. Now this has to be stopped, and that is the most important challenge we want to address at this moment at our group. India is a huge agricultural country. We generate huge amount of agricultural residues. And when you burn residues in the field, you generate lots of smoke. Delhi becomes a gas chamber because neighboring state burns their residues. Can we use those agricultural residues to convert some useful product like biofuels?
Every year, 500 million tons of agriculture waste are being generated, of which almost 300 million tons are either being wasted or burned, which is causing the air pollution that can be used to generate 1 billion liters of ethanol using second generation biofuel production process.
When you use bioethanol, it is coming from a microbial fermentation of sugar. This sugar can be either from sugarcane or it can be coming from the starch of the corn. These are called first generation biofuels because these are a food material. You cannot afford to use food-based feedstock for making fuel. Therefore, we shift to the next available feedstock, which is a non-food portion of the plant, and we call it as a second generation biofuel or lignocellulosic based biofuel because those plant cell wall are made of lignocellulose. We need to get rid of the lignin first, so there is a pre-treatment process. It's mostly a chemical engineering problem. Our role actually comes from the second step, where these cellulose and hemicellulose needs to be broken down into the monomeric sugar. But cellulose is very, very crystalline in nature. Therefore, it is very difficult to digest and enzymes are needed in a very large quantity. The overall cost becomes very high. We always compete with the petrol price, and that is the major challenge. Can we produce a very, very efficient cellulases and hemicellulases so that we can accelerate the process of digestion and convert them into the sugar?
In the course of bioprospecting, we discovered a fungus, Penicillium funiculosum, that was a hypercellulitic fungus whose secretome worked much better than the commercial available secretome. In our lab, genetic intervention started to make it more robust, and that has given almost 5-fold increase in the cellulase production. So we can tweak the fungus to produce more enzyme. First, we start from the small scale, that is the shake flask, and when we find that this variant of fungus is working fine in the terms of enzyme production, then we go to the large scale towards fermenter of enzyme. Then we scale up to 15,000 liters in industries. ICGEB Delhi is one of the component of ICGEB.
It's a very unique place to work on, because that's a place where you do both basic fundamental science as well as translational science. Whatever we are doing at ICGEB is in line with the Sustainable Development Goal number 7, which is affordable and clean energy, because our research will produce biofuels and we are going to make the technology affordable so that it can be accessed in the market by the society. We all are facing health problems, food crisis because of the climate change. And perhaps if we don't look at it now, we will be in real trouble in the future. By working at the renewable energy area, I think we are going to solve many of these climate change problems.
So if we are successful in generating second generation biofuel, the earth will be a better place to live in.